Okay, now let's go to the Poisson distribution. The Poisson distribution is another discrete probability function. And in the Poisson distribution, we are interested in the number of occurrences in a time period. Okay? Now, number of occurrences, this is a discrete variable, and time period is a continuous variable. Okay, it is a discrete number of elements in a continuous whatever it is. So, and in this case, for example, we are dealing with the number of customers that arrived every hour, the number of failures that we have every square foot, the number of gas stations for every 10 miles in the highway. Okay, so it's time or distance or area or whatever that is continuous, and the number of elements in that particular interval, if you will. Okay, now we have only one parameter in this case, and this is mean, the mu, and the mu is the expected value of the function. We have the function defined f of x is equal to mu to the power of x e to the minus mu divided by x factorial. Okay, so mean, the mu is the expected number of occurrences in the time interval. And for this one, and of course E is in your calculator, and has to be in your calculator. E is equal to 2.7182812828. X factorial is whatever we are considering, and so on. So that's it. That's it. Let's do problem 38. That's it. That's everything about the Poisson distribution. This is my f of x. This is, remember, this is f of x. This is x. And this is the values. Okay? Now, let's do problem number 38. It says, consider a Poisson distribution with mu is equal to 3. Mu is equal to 3. Write the appropriate Poisson probability function. The appropriate probability function has to be equal to this one. This is the probability function. Mu is equal to 3, so it's 3 to the power of x, e to the power of minus 3 divided by x factorial. This is my f of x. This is the function for this particular case because mu is equal to 3. B, compute f of 2 is equal to what? Just put the 2 instead of the x. 3 to the second power, e to the power of minus times e to the power of minus 3 divided by 2 factorial. Okay, and what is that? Use your calculator. 3 squared is 9. This is 2 factorial. 2 times 1 is 2. E to the minus 3 is equal to 0.049. 49787, whatever. So it's times 9 divided by 2. This is equal to 0.2240. The probability that I'm going to find two successes in the time period is going to be 0.2240. Okay? That's it. The rest is pretty easy. I mean, the rest of the things are pretty easy. F of 1. D asks you to compute the probability of x greater or equal than 2. Okay? So you have to have f of 2 plus f of 3 plus f of all the f's until the infinite, if you will. Or since this has to be, everything has to be equal to 1, you can say, well, this is equal to 1 minus f of 0 plus f of 1. So I only have to add two numbers, and then those numbers is the complement, because everything has to be equal to 1. Now, another good news about this is that we do have tables as well. And that table is on page 999. On the top you find the mu, and over here you find the x. So let's find mu equal to 3. That is on page 999. It's in here. And mu is equal to 3. Right. And f of 2 is equal to 0.2240. It's exactly what we have here. 0.2240 is exactly what your book says. Mu is 3, okay, and x is 2. The probability is 0.2240. It's exactly the same answer. So you don't have to do this calculation unless you cannot find mu in the tables. For example, if mu is equal to 3.07, there is no 3.07 in my tables. So I have to use the formulas. So, let me give you the review of the chapter. That's it. These are the only two probability distributions that we're going to cover. The binomial distribution and the Poisson distribution. The binomial distribution, we are dealing with a multi-step experiment, and in each payment that is independent from the other, and each step may have two possible outcomes, what is called success and failure. The probability of success is p, and the probability of failure is 1 minus p, and we are interested in the number of successes in n trials, and that function gives you, okay, in the binomial. This function f of x and x, p to the power of x times 1 minus p to the power of n minus x gives you the probability of exactly x successes. If you want to know 2 or more, then you have to add 2 plus, f of 2 plus f of 3 plus f of 4 and so on. Okay? The other probability distribution, the other continuous probability distribution is the Poisson, that is dealing with the number of occurrences on a particular time period or distance or area or whatever. And again, it's pretty easy. For both, you have tables, and that's it. I mean, it's pretty easy. And the f of x gives, in this case, probabilities. This is x, and of course the function may take only a few possibilities in your sample space.